The city car itself, as I mentioned, is very compact. It's foldable. It can be driven when it's folded. We've designed the interior seating to articulate so your head doesn't hit the windshield when it's folded. And you can drive the vehicle when it's folded in very slow speed, because there may be a parking space that you're looking at that you find that's very small, and you want to fold the vehicle up first, drive it into the spot, and then get out. In fact, the door opens to the front. It's a clamshell type of door. And this vehicle, you can park perpendicular to the curb. So you can step out directly onto the sidewalk, which is much safer than having a door swing for bicyclists, of course, and other vehicles. So that ability to spin on its own axis is really useful, because I can get into the vehicle, spin in the direction I want to go to, and head out head first. So no need for reverse, no need for parallel parking, no need for K-turns, none of that stuff. Makes getting a driver's license very, very easy. And the vehicle is by-wire controlled. So each of the wheels are controlled independently through electronics, not through a mechanical device like a steering wheel. So we can actually program the type of driving ability that the vehicle can have. So in the very beginning, while you're learning to drive this vehicle, perhaps it drives like a normal vehicle. As you get better and better, like a video game, you can add more superhuman powers to the vehicle. Once we have the vehicles ready, and we're really moving towards that currently, we're going to build one prototype, and once we have that one prototype, we'll build another 20. That 20 will test all the kinks and basically we'll work out all the kinks in the 20. Crash testing, integration of HVAC systems, and driver's interface. All that stuff needs to be sort of tested in those prototypes. After those prototypes are done, we will then deploy a pilot of perhaps 50 or 100 of these vehicles in a neighborhood of a city, any city, a city that's willing to test this system out. So the group that we're working with has created these number of sites for which we can pilot the system. The piloting of the system is to test not only the performance of the vehicle, but also the interaction between the charging stations and the vehicles and the humans that will actually have to rent and use these systems. So the user testing, which will of course test the accessibility of the vehicle, how it's driven, and then testing of the operations. So the service side of things. Who's going to be running these programs? Who's going to be servicing the vehicle? How do you deal with the redistribution? How do you tap into the electric grid? So the operations side also needs to be tested. And the best way to do that is to deploy a small number of these in a limited area and work it out for over, do a test for about 3 months or even 6 months. The other aspect of testing is, of course, to come up with a management system that is optimized for redistribution. So when you have a fleet of 50 vehicles, you can begin to examine the patterns of movement. How many vehicles are moving from one location to the next? Is there going to be over-demand in one location? Is there not going to be enough vehicles in another? You can build a very good understanding of the patterns of movement so that you can create a mathematical model for which you can simulate what the movements patterns will be like, so that we can readily deploy actively redeployment strategies, redistribution strategies, and even grow the network as well. So the beauty of mobility on demand is that when you place the charging station down, you can have 5 vehicles or 10 vehicles, depends on how much space you have. It may turn out that you don't need as many vehicles, and the only way to know that is through deployment. Once you deploy this, you can begin to contract and expand.